Hi guys, welcome back. In this video, we are going to talk about AWS Lambda, and I do have a few slide decks. Let's quickly cover that to understand the basic concepts of what is Lambda and its components, and then we will quickly cover the demonstration of this service to understand a little better. So, what is Lambda? It's a serverless compute service. Basically, run your code in response to events and automatically manages the underlying compute resources for you. So, this is a service which this will be triggered. This will trigger your code based on some of the events. The event basically come from any of the resources like S3 bucket or DynamoDB or Kinesis, any of underlying infrastructure. There is a list of services. We will cover that. Lambda runs your code on highly available compute infrastructure. So basically, you don't have to worry about managing the server or capacity, provisioning, scaling, or patching, security management, nothing. Everything will be taken care by AWS Lambda service. All you have to do is just bring your code. The code will be executed based on the event which is triggered from the actual service. When I say the from service is nothing but S3 or like similar services like or DynamoDB or any other services. The code you run on AWS Lambda is called a Lambda function. After you create a Lambda function, it is ready to use right away. It is like formula in Excel sheet. You really don't have to wait for a long time. The moment you create the code, if the event is triggered, the code will be executed right away. Each function includes, when you create a function, it includes your code as well as some associated configuration information, including the function name and the resource requirements. Once you upload your code, you can associate the function with the specific AWS resources. As I said, it could be a S3 or DynamoDB or Kinesis or SNS, any of the service. So, what language is this AWS Lambda support? So far, as of today, Node.js, Python, Java, C, these are all the supported codes, supported language. Also, your code can include existing libraries, even the native ones also. So I would recommend to read the public documentation to understand more about these supporting codes. So how does Lambda secure your code? Basically, whenever you upload your code will be stored in S3. Basically, that file object will be encrypted at the rest. So which has been taken care. Also, AWS Lambda performs additional integrity check while your code is in use. You can also, so how long the function can be executed? This function, Lambda function, can be executed maximum of 300 seconds. So you cannot run any job for more than 300 seconds. You can set the timeout starting from 3 seconds, and that option is possible. So anyhow, when we go to the actual demonstration, you will understand this much more better. Okay, let's understand because this is a code. You should understand how that code needs to be written. So the programming model, how it's supposed to look. This is what we are going to cover now. I'm pretty much in this slide deck. I'm pretty much going to talk about Python code. I'm sure which is familiar, which is similar to Java or Node.js, but in this slide deck we'll talk about the example we are going to cover here. We are going to talk only about Python. So here are important components: handler, context, event, logging, and exception. So this is how your Python code function will exist. You will always create your function with the function name. Basically, that's the handler. I'll call function name. and this handler is going to carry two parameters. One is event, another one is contest, and rest of some of the values we are going to feed. So also there are some important components we are going to cover. When you create a lambda, of course you are going to have source service. It's not server, I'm sorry, I'll correct it. Source service, where the event get captured, like S3, Dynamo, Kinesis, and then the Lambda service where your code is going to be running, and the CloudWatch log group and log stream to capture your logs. Uh, so this is very important. So Lambda will automatically use CloudWatch and log stream to capture your logs. And IAM role, this is something we need to create the role with the following policy. So what is this role is for? By using this role, we are telling AWS Lambda as a service can create the log group, log stream, and write the logs into that CloudWatch. So we are giving the privilege by attaching this role so that the service can do on behalf of us. And also we are telling, I'm going to give you a demo for S3 put object and that specific event based scenario. So for that, I gave all S3. I said, any actions on the S3, and the lambda can perform this any actions on the S3 on any resource on my account. So any bucket, any action, this lambda function can do the role where I'm attaching. So these are all the four important components: the source service, the lambda itself, and the CloudWatch and IAM. Okay, now let's cover the programming model a little bit more. What is handler? Handler is a function. Lambda, calls to start execution based on the function name. When lambda function is invoked, lambda starts executing your code by calling the actual handler function. By using this name, it's going to call it. So AWS Lambda passes any event data to the handler as the first parameter. So we talked about this, right? There are two parameters we are going to pass into the Lambda, event and contest. So when the source, let's say the scenario, the source is S3 bucket, the event is nothing but the object we are putting. Anytime we throw any object into the S3 bucket, that's going to be considered as an event. So that event needs to trigger my Lambda function to delete the object or copy the object to another S3 bucket. In that scenario, so AWS Lambda passes any event data to this handler as the first parameters. Okay, how Lambda will get this event? That's the source. The source will send this event data to this Lambda so that Lambda will give it to this handler. And the second, so this is the event. Okay, so the event is, in this example, as I mentioned, I have a cloud trail. The cloud trail is basically, it's kind of log for your AWS account and services. Anytime, any API calls made to the service, that will be logged into the cloud trail. Let's say I'm copying that to my S3 bucket. That will be considered like one event. That object will be, created into the S3 bucket, and immediately that event will be captured. That event will create one event record and send it to S3. So I throw the object, that will be an event triggered to my Lambda. My S3 also will send this S3 configuration file. It's nothing but the event object. We'll see some example, and then my code will be executed to send the data, send further process like send email to my email ID by using SNS or whatever your code says. So this is an example. This will give you much more clarity. When I say event, the event is always from the source. Let's say in the S3 I mentioned I'm putting the object. I'm copying the object. When I copy the object, S3 will create this record and pass it to your Lambda function. This is a sample record, which contains the timestamp, the object ID, the object name, size of the object, source bucket name, and what kind of action it is. This action is like put object or get object, all those information. So this is another example. Delete, same thing, timestamp, object name, and bucket information, and what kind of event it is. Object removing, I'm deleting. So anytime any event happen, this is how the event record is captured. This is actually captured from the source service itself and send it to Lambda. By using this information, Lambda will get some critical information of your the event and pass and process your code. Okay, so far we talked about handler and event. The third one is contest. The contest is AWS Lambda uses this parameter to provide runtime information to your handler. This parameter is of the Lambda contest type. So Lambda also passes a contest object to the handler function as a second parameter. You already saw the sample code. So this contest object, your code can interact with Lambda itself. So when you write a code, you are writing a code getting by using the two data. One is a event data, another one is a contest data, and then you do whatever you want to achieve with your code. So the event data is going to carry the source service informations like S3 bucket name, object name, when it is created, what actions happen, all those. The contest information is going to have runtime environment, like what is the function name, where it is storing the log, and how long it is running, how many more execution time is pending. So this is the contest information. So using these two critical data, you can do your own function. Okay, this is so basically the contest again we are covering here. It's going to have a it's going to tell you how much time it is pending. It's the job is getting executed and the log group name and log streams associated and request ID. So let's see the example. This is the code example. When I can print some of the contest runtime and information details, like by calling contest dot log stream name, log group name, contest dot request ID, contest dot the memory which is being configured to the function, contest dot get remaining time, how long it is there. So within your code you can use this runtime information, and and you can build your own code. So refer this link. This tells you much more examples and informations. Okay, and logging, the another component. So far we covered handler, which is function name, event, which is coming from source, carrying all critical information of the source and actions and objects and everything, and contest, which is nothing but the runtime environment of the Lambda function. And logging, you can use, again the name itself says, you can include in your code to get the logging informations, or you can customize your own log. You can say, hey, when this happened, you can log in this way. Something went wrong, or hello world. It's custom logging. Okay, it's an example piece of code. It's a best practice. When you write a big code, every step what do you want to log, so that for future reference. And exceptions, in case of any failures, how to handle the exceptions. That is also the sample code. I'm going to pass this. You can refer that. Basically this exception is, if it's a kind of JSON format, it just written. If your Lambda function raise an exceptions, Lambda recognize the failure and serialize the exception information in JSON format, like a below example. You can write your own custom exceptions. That's the idea behind it. Okay, let's go to the practical example scenarios. Look at this picture. In this picture, the user throws the object. The object goes to S3 bucket, and immediately the service, S3 service itself finds the event, because there is some incident happen, put object, and send that to Lambda with the event information. Remember we saw the put object event record. That information will be passed to Lambda, Then Lambda will quickly validate the IAM role, and if everything looks good, the policy, then by using the event information, it just execute your code, the code you have already attached. This is the example. Okay, let's go a little bit more. The same little broad. In this scenario, the user is creating an object into S3 bucket, and S3 finds that an event and send the event notification to Lambda. Basically, it's triggering your code to execute. And of course, whenever it executes the code, it first validate your IAM policy to ensure you have appropriate permission. Once everything passed, then your code will be executed. In the code, I'm saying, hey, if anytime new object comes, copy the data from the source bucket to the target bucket. That will be executed. So this is the one, I will give you a demonstration after this slide deck. Okay, so I'm pretty much done with the slide deck. Let's go to, let's go to the actual scenario. Then we'll come back if anything missing. Okay, so in this example, this is my IAM policy I'm going to use. I already created a role called Lambda S3 example role, and I attached the policy, some simple copy object policy. Basically, this policy has permission for Lambda function to create log group, log stream, put event. I'm giving a CloudWatch access because, as I mentioned, Lambda, when it executes, it need some storage logging locations to store the log information. So I have to give permission so that Lambda will write the log into the CloudWatch. So this is for CloudWatch logs, this portion. Okay, I'm giving complete access. Okay, it can create the name with any name of the log stream. Okay, and then, or you can, if you want, you can create the log stream well in advance and give that name also. Here I'm telling you can create whatever. Second portion is in this example I'm going to use S3 as the source, and its event is going to be used to trigger Lambda. So basically it's going to Lambda, I'm allowing Lambda to do any action on my S3 bucket. When I say S3 star, it can do S3 get, put, delete, anything, copy, any actions. And same thing, it can happen on any resource, like any of my bucket under my account. Okay, this is what this policy. Okay, this policy is the one I'm going to attach, S3 copy object policy. This policy name can be anything, the role name can be anything. Only thing, ensure this is the important piece here. Okay, so this is the example role I'm going to use. Now I have already created one bucket called test 2525. This is the S3 bucket I created. This bucket right now has no data. It's an empty bucket. Okay, this is the bucket. Let's do two scenario. The scenario number one, I am going to create a Lambda function pointing to this bucket, source bucket. Anytime I copy any object into this bucket, Lambda function will be triggered and it will delete the object, whatever object I copy. That's first scenario. The second scenario, anytime I throw object into this bucket, Lambda function will be triggered and copy this object into the another bucket. Like test 2525, I do have another bucket called test 3030, test 3030. So it will copy from 2525 to 3030. So this is the two scenario we are going to test in this video. So okay, first one. Let me quickly create the Lambda function. Create this is my old function, forgot about it. Create a new Lambda function. When you I'm creating in the console, you can create in the CLI too. So here the blank function, this is a way custom, you can do your own way, or you can pick any of the existing template. Like if you want to configure for Kinesis or DynamoDB, you can pick the template, you will get a fair idea, but I'm going for this one, blank. Here configure trigger. So remember the component we should have from where we are going to capture the event. That's more important. So that's the source. So these are all the source today Lambda supports. So I'm going to pick S3. Okay. So what bucket? I have so many bucket. I'm going to pick test 2525. Okay. What type of event? Whenever objects removed or whenever objects created, I am going to pick whenever objects created. Look at here, even whenever the objects created, I can pick specific type of object. Put is also type of object creation, copy, post. So many way you can create the object. So I'm going to pick any way I create the object, just trigger it. Prefix, just leave it blank. Any, if you have within the bucket, if you have any folder, then you can use it. Let's say my bucket is source test 2525. Let's say I have any folder. Inside the folder, if I wanted to monitor, I can pick that. Here I don't have any folder, so just leave it. Suffix, and a suffix is like, how the file, the object, whatever you are throwing, let's say jpg, any file with the extension .jpg, then do the action. Let's say if it is with .txt, don't do anything, only for .jpg. That's one. That's it. Enable trigger. So trigger is enabled. Now just do next. Give a function name. I'm going to say this is the function. It's going to be a demo for S3 delete lambda. This is my demo. It's basically delete objects by lambda. Okay, and Python is the code I'm going to use. I already have my piece of code. This is the code. This link is already, I'll share you the link later for your future reference. I'm just copying my code. What this code does is, let's quickly review the code. This code is a Python which imports some of the libraries, JSON, Bota3, time, everything. Bota3 is very critical because Python uses Amazon SDKs using Bota3. Bota3 is Amazon SDK, and so I'm just referring, Bota3.client S3. Anytime when I'm going to say S3, basically it's going to call Bota3 SDK. That's what it means. And I'm creating a function with the handler. Remember the programming model, the first one is handler, event, and contest, these two parameters. So the handler name is what I'm giving is lambda handler, and two parameter I'm passing, event and contest. Remember the event, whenever I put the object, the S3 put, so this file will be, this object file, S3 put file will be sent to lambda. So using this metadata, like information like bucket name, object name, object size, lambda function is going to read all those information. So event parameter basically read that file. So this is one. And contest is the runtime environment. So by using the event, I can get bucket name and bucket object name. Bucket name, look at here, bucket name equal to, from the event record, just take the bucket name. From the event record, take the bucket name. This is the bucket name. I'm going to take this bucket name. This bucket name, name of the bucket name. So I'm taking it from this record. Key is actually the object name. Take it from the record S3 object key. So take it from object key, from the S3, from the object, take the key value. So store it as a bucket and key. So how I'm capturing my bucket name and the key name, that's object name, from the event record. Basically the event record will be passed to this lambda function at the time of put object, when you put the object. Okay, as soon as you get that, what do you want to do? I wanted to do delete. I'm sorry, I commented. Let me uncomment. These are all simple print, just to give you the log. Basically this says, hey, I'm wait for some time till object is exist. Once object is exist, do the response, do this printing. Printing is nothing but I'm just printing the bucket name and key name, those things, and then basically this is the Bota3 I'm calling S3. Call this SDK to delete the object by bucket name and key name. Bucket name, key name is already captured here, right? Bucket equal to this bucket, key equal to this key. So just delete the bucket. Okay, and if in case of any problem, let's say I'm passing the wrong bucket name or wrong key name, object name, it throws an exceptions. So we already talked about what is exceptions and what is logging, all those informations. Okay, So it's fairly simple. Let's say if you want to capture contest information, you can even capture here. You can call contest dot how long the job is running, contest dot log group name. You can print it for your reference. I didn't do that. I think it is there in another example. We'll talk that later. Okay. Now, I don't have any specific environment variable. It's optional. If you want, you can give. And handler, remember handler is this is, I'm using the default handler name. Here I gave lambda underscore handler. If you want to give your own name, for example, deleting the object, if that's the handler name, ensure that same handler name is given here. Okay. So that your handler know how to call your function, how to call your code. And the role, I'm going to use my existing role I already created. So my role is example role. We already talk about this role. So that's the role I'm going to use. And amount of memory. I'm just going, it's a very simple code to delete the object. So I'm just giving 128 MB of memory. You can choose up to 1.5 gig of memory. Uh, Remember the lambda code, this any code you are, any function you are creating which can run for 300 seconds. So the memory what you are picking, that much faster your code will run. If you think your code is timing out, you may need more resources, so increase the memory. So based on the memory selection, Amazon will give you the appropriate CPU power actually. For example, if you are picking 128 gig, you will get, assume you are getting one CPU. If you are going for 512 gig, you may get 5 CPU. That's a kind of proportional way it will give, just for example purpose. Also, you can set the timeout. If you think your code will run just for you are expected to run for only 4 seconds, but you want it is running for more than 4 seconds, timeout, just give the timeout value. And dead letter queue, in case of while running, whatever errors coming or any messages you wanted to pass it to notifications and email subscriptions, or you wanted to send a queuing, so that used based on that queue you wanted to trigger another one, you can create that. We are not going to use this as default, leave it. We don't want it. And VPC, this is another cool thing. Today AWS Lambda, when you create, we are creating in Amazon resource, right? So on their network, it is not specific VPC or anything. It will be created anywhere randomly, and then the service will talk to, because of IAM policy, the service will talk to your Lambda, will talk to your S3 by using endpoint, in the public network way. If you think, hey, you know what, I want to create a Lambda function, I have very secure code, I don't want this code will talk to my DynamoDB or any other resource like RDS, I don't want to come through public network, then you can pick VPC, so that when the code launched, your Lambda itself will create a resource from the private VPC within your subnet, from where your code will be executed and communicated between your services, which is much more secure. I'm just leaving it as a default for this example. And finally, KMS, key management service. I'm not familiar into this, so let me not talk about that. So I'm just leaving it as it is default. Next, so just verify and create a function. So a function has been created. Okay. So function is created so fast. So your code is here. If any error, you will see code error, but I see everything looks good. And your configuration trigger, we are triggering from the bucket test 2525, and any event happen in this bucket, you are going to get it. Not any event, put any create object, and you can monitor, is there any invocations, how long it ran, any error, throttling, all you can do. Okay, now it's a time to test it. Let's go to S3. This is my bucket. I can, if I want, I can put an object in this way too. AWS S3 CP, my object name, happy face. This is my object, S3 colon slash slash, and test 25. This is the CLI way I can copy the command, or I can copy this way, or I can the command console I can go and upload and just go and happy face.jpg, just click the file and start upload. Either way it is same. So I am uploading the file. File has been uploaded, right? Now go to my Lambda should invoke, correct? So if I go here and then just refresh this guy. Okay, first time when you create the Lambda function, let's allow a few minutes for that resources getting created at the background. um, you can also watch the logs. Okay, let me see. It's S3, right? Let me refresh it, because part of our code, it should delete the object. See, it's deleted already. I uploaded the object, it deleted. Let me try again. Upload the object happy face and start upload and refresh it. I see the file now, and when I refresh again, my file is gone. Basically, Lambda function invoked and deleted it. How do I ensure it is my Lambda function? Usually CloudWatch logs will take minute. Minimum is the minute, 1 minute to refresh. That's what we didn't see last time. But now you see, it invoked one time. Basically, it's invoked two times. You will see, after a minute, every 1 minute only, my console will get updated. Okay, so no errors. Okay, whatever. So click on View CloudWatch log. This one, CloudWatch log. Anytime when you create a Lambda function, remember in the IAM role we allowed to create a log group name. So you can see the logs captured under AWS Lambda, my function name, demo s3 delete. That's my function, Lambda function name, demo s3 delete. So that's the function name created. Here I see one log stream name. If I go to the log stream name, this is very critical. This carries based on your code. Remember my code says print something, right? Print rate of waiting and print the key name, deleting the object, and any exceptions. All those things you can see here. This is my key. That's a first print line. Another, then it captures my key name and it says deleting the key, and then it deleted also, deleting the key name. Okay, so basically the code, whatever you say, if any error, you can see that by looking at this log. You can troubleshoot much more better. So when you write a code, write a meaningful exceptions, meaningful comments and codes, or whatever you print, make it step by step. I would say for every functions, create proper print statement. In that way, we know where it failed at least, and how long it took. It took like 200 milliseconds, so that's fine. So that's fine. So this confirms, my objects got deleted from by using Lambda function. This is one. And let me create another. Let me create another code. Okay. Let me create another code. So another function, so that we will copy the objects from to create another Lambda function. Create a function s3. My source is s3, and I'm going to test 25. Any objects created, it will be copied to my target. Okay, like jpg, enable trigger, and next. And my function name is copy object between object to test 3030 bucket. This is another bucket. Okay, and okay, let me copy my code. This is my sample code. Let me copy this sample code. Okay, this code, what this code does is it just same, importing all the libraries and calling SDK Boto3 and getting even bucket source bucket name. Only thing here is when I create the name. Okay, part of my code, this is very important. When I create the name of the function, I need to ensure, because say my objective is to copy my object from source bucket to target bucket. So the source bucket information, I can get it from the event object, correct? The event will, S3 will send the data. So my source bucket, I can get the name of the bucket reading the event record, and object also I can get from by reading the event record. But the target bucket, I need to pass it logically, right? So what I'm telling is get the target bucket from the contest during running the job, contest the function name. Remember that's a runtime. So contest dot function name means, whatever function name, that's what, my target name, target bucket name. So what I'm going to do, I'm use the target name. Test 3030 is my target bucket. So I'll give test 3030. Okay, 3030 exists. So I'll say 35 something. Yeah, or 4040. I'll create one bucket, test 4040. So what it's going to do is I'm going to, it assumes, not assumes, it gets the target bucket name from the contest, from the runtime environment, by reading the function information. This function name is test 4040. Okay. And the rest of all print statement. Okay, this is something I would like to cover. It is printing, the log group name where it is storing, log stream name, request ID, how much memory I configured. All the information is going to print because I'm reading the contest, the second parameter. Okay, runtime environment. And then, it's basically finally it's going to wait for object and then copy the object from source bucket to the, target bucket. Target bucket is, I'm going to get from target bucket, I'm going to get from function name. Source bucket, I'm going to get from here. Any exceptions, it's going to throw any exceptions. Okay, everything looks good. And no, as usual, no environment variables I'm going to use. The handler name, the same thing, function name, and the role, I'm going to use the existing role, which is example role, because which has full permission to copy, delete everything. Same memory is fine, and I'm not going to talk about this. All default I'm leaving. Just create and create a function. So only thing missing is the test 4040. The bucket is not here. I'm just creating one bucket called test 4040. Okay, create a bucket. Okay, so if you look at test 4040, there is no data. It's empty. Okay, so now what I'm going to do is in test 2525, I'm going to throw an object. That object will, copy it into my target. So today, if I look at test 2525, which is, I think, which is, referring my older Lambda function. Let me, yeah, because for a previous demo I attached, right? Let me ensure. See, it's still with the demo. Let me add to the new function. New Lambda function is 4040. Otherwise, it will just delete it. I don't want to delete. I want to copy the object from here to there. So I'm using the new. Earlier it was with the delete Lambda. This time it's a copy Lambda from there to here 40. Okay, wonderful. So everything is ready. Now I'm going to put the object, add file, and I'm just copy the JPG file, start upload, and look at here. So test 2525 created. Now go to test 4040. See the file exists. Wonderful. So file has been copied. How do I verify? Same way, go here. This is my function test 4040. If I go to monitoring, there is one invoke. There is no error. And if I go to CloudWatch, see again the new directory will be created, part of the function name test 4040. If you go to CloudWatch, you will see CloudWatch log group called test 4040 based on the function name. I have a new log stream name. This log stream name says, okay, it's still refreshing actually. It takes some time actually to write it, but however it says copying the object. It's waited for some time copying the object, and yeah, it ran for 961 seconds. The print functions and all you can see, log group name, log stream name. Why this is printing? Because in our code we mentioned clearly I want to print the log stream name, I want to print the log group name, I want to know the request id, some of the contest information we were looking, right? Those informations are here: log stream name, log group name, request id, memory, and those informations, and copying from object from this to this, all I printed, part of my I printed part of my code. So I guess that's it. So I'm sure this will be helpful to you guys. What I'm gonna do, I'll keep these. This is the bucket. These codes are already there in the public. You guys can access it. I mean, download it. I will send you these two examples, whatever I covered. Those example codes are links are here. You guys can this is my bucket name, and for deleting the object, this is for copying the object, and you can use it for both the exercise. And this is something I didn't cover. Instead of doing everything in the command line, you can in the console, you can do it in the command line also, by running simply AWS CLI to create a function in the region with a function name, with your own package code location, the IAM policy. You can do this also. It's an option. That's it. So please let me know if it is helpful, or if something I need to correct it. Thank you for watching. Have a great day.